So let's talk about basic statistics. So statistics refers to the science of collection, analysis, interpretation, and presentation of data. There are two major types of statistics: descriptive statistics and inferential statistics. Now, with descriptive statistics, it's also known as enumerative statistics. So this includes organizing, summarizing, and the presentation of your data. It describes what's going on in the data, and we can get that through like histograms, pie charts, box plots, stuff like that. It would be an example of descriptive statistics would be like your mean, your median, your mode, anything that is numerically expressed. Then we have inferential statistics or analytical statistics. Now this includes any predictions and conclusions that we're going to draw from a sample to a population. So it makes an inference from our data to a more general condition. Now some tools that we use in inferential statistics would be like a scatter plot diagram, hypothesis testing, and other tools. So with analytical statistics, the main objective of statistical inference is to draw conclusions upon a population. So this is going to be based on information available through a sample. And a sample from the population is collected, and an assessment about that population parameter is made from the sample. So let's say that we have a management team of a cricket council that wants to know if the team's performance has improved after recruiting a new coach. Is there a way for the improvement that can be proven statistically? Well, we have to do something called a hypothesis. So the first hypothesis we make is something called the null hypothesis, which is the assumption that Coach A and Coach B are both effective. So we're going to assume the status quo. So our null hypothesis is the fact that Coach A is equal to Coach B. There's no difference. So that would mean that our alternate hypothesis, which is the assumption in the efficiencies of the two coaches, do differ. So that would mean that Coach A is not equal to Coach B. Now there are two possible errors that can happen when collecting sample data from a population. And based on that, a conclusion on the population can be made. Now a type 1 error occurs when the null hypothesis is rejected when in fact it's true. So a type 1 error is also known as a producer's risk. Chance of committing a type 1 error is also known as an alpha error. So the maximum chance of committing this error is just 5%. Now a type 2 error will occur when the null hypothesis is accepted when it is in fact false. So a type 2 error is also known as a consumer's risk. This is the chance of committing a type 2 error, which is also known as a beta error. The maximum chance of committing this error is 20%. Now the central limit theorem states that for a sample size greater than 30, the sample mean is very close to the population mean. So when a sample size is greater than 30, the sample mean approaches normal distribution. In such cases, the standard error of mean, or the SEM, that represents the variability between the sample mean is very less. So selecting a sample size also depends on the concept called the power of the test. So here is a graphical representation of the central limit theorem. Now the plot of the three numbers of 2, 3, and 4 looks like this. Note that the total numbers of 2, 3, and 4 are 6 each. Now the plot of the sample mean of 9 samples of size 2 each looks like this. Now the central limit theorem concludes the following: that sample distributions are also helpful in dealing with non-normal data. If the sample data points are taken from a population and the distribution of the mean of the samples is plotted, it's called the sampling distribution of means. And that the sampling distribution will approach normality as the sample size increases. Now this concludes topic 2. In topic 3 of measure, we'll discuss statistical distributions.
you.